Welcome to today's physics class. In today's class, we shall continue with electric field. In our previous videos, I solved some questions relating to electric field, and I also gave an illustration to Coulomb's law. So today we will continue with more examples. So look at this question here on the board. The question says 2-point charges, each numerically of 10 raised to power minus 6 coulomb, are 0.15 meter apart in free space. Find the electric field intensity or strength at the point midway between the charges. If we have two conditions here, if the two charges are both positive. Number 2 question, if one charge, this one is charge, one charge is positive and one is negative. So this is a very simple question. They want us to find the strength between the two charges, and both of them, the charges, let's say for example, look at what we are trying to depict here. Okay, let's say this is a point here, this is a point here, okay, and now the two charges are separated. Let's call this one Q1, let's call this one Q2, and the two charges, they are of the same magnitude, 10 raised to power minus 6 coulomb. Here is also 10 raised to power minus 6 coulomb. Now we are asked to find the electric field intensity midway. The total distance between them is what? The distance from here to here is 0.15 meter. Okay. Now we are requested to find the electric field here intensity. Electric field intensity. Let's call this point here. Now we are going to have our E2. Then if we go like this, if we move towards this charge, if we want to calculate the strength from here, we can call this point P here. Okay, that is the point midway. Okay, so we can call this one E1. All right. So we want to calculate the strength of the field here. So if we decide to share it, since we say that from here to here is the distance between the two of them is 0.15 meter. So if we divide this one by 2, we're going to have here, So this will be 0.075. Okay, 0.75. Okay, 0.075, 0.075 meters. All right. So now we are going to apply the formula for calculating the electric field strength. Remember, in our previous video, the question I solved there was in the case where the potential difference and the distance was given. Now in this case, since the distance is also given here, then the charge is given. So we use the formula that says the electric field intensity is equal to the force per unit charge. So that is the formula I'm going to use here. So let me clean up this place. So let's take this side. Okay. Now this is what we need. We need this. We already have this here. We have this. So Q1 in this case, Q1 is equal to 10 raised to power minus 6. Then Q2 is the same thing as 10 raised to power negative 6 coulomb. Okay. So we want to find the strength. The strength, the formula is what? Force per unit charge. Okay, which is the same thing as equal to what? Your F all over Q. It could be Q or capital letter Q, as the case may be. But do you know that in this case, how do we get the force? Because the force is not given. Remember, in an electric field, we are talking about the force of attraction. According to Coulomb's law, your F is equal to K, Q1, Q2, all over R squared. R squared here is the distance between the two of them. So if we decide to use this one here to replace this, okay, in this case, so this Q here, since both of them are the same, Q1 here, Q1 is equal to Q2, according to the parameters given to us here. So let us substitute this one in this case here. So that we can now have E equal to K Q1 Q2, alright, all over R square divided by, so if you divide, at the end of the day we're going to multiply, divided by this Q, 1 all over what? Q. Okay, so in this case now, since Q, this one and this one, they are the same, so this Q can cancel any of them. Alright, so at the end of the day we now have our E equal to what, which is the strength, electric field intensity, equal to K Q, just call it Q, alright, K Q all over R square. So this is the formula we are going to use now to calculate this electric field intensity between this one of these plates here for A. Alright, so when the both of them are both positive, so we are going to use this one to calculate it. Let's calculate the strength now. E1 at P. So we have the formula. But remember, this our K here has a value. K is equal to 1 all over 4 pi resistivity, permittivity, which is the same thing as what? 9 times 10 raised to the power 9 Newton meter square per coulomb. That is what, this is what we are going to use to replace this here. And our R here in this case, since it's operated at midway now, so we are not going to use the total distance. We will use 0.07 because we want to calculate the electric field strength at P. It will be between here and here. Okay, so our Q now, we have just Q, which is for 10 raised to the power minus 6. So our E1 at P is equal to this one, which is this constant here that we are seeing here, 9 times 10 raised to the power 9 times, which is our Q. Q is what? 10 raised to the power minus 6 all over. The next one is what? R squared, 0.075 all squared. Okay, so what I want you to do for me now, use your calculator, punch it out, use this one and this one can go, the power here, you can take 6 away from this, then just evaluate and get the answer straight for that. So let me clean up this side. Okay, so I haven't done that. After doing that, you're going to have your E1 equal to 1.6 times 10 raised to the power 6 Newton per coulomb. Okay, so in this case, after you have used the calculator to evaluate the whole of this, this is what you're going to have: 1.6 times 10 raised to the power 6 Newton per what? Coulomb. Since we said that what, both of them are separated at what, midway, so the E2 now, E2 at P is also equal to the same strength. It is the same strength that we have at E1. It's the same strength we still have at what, E2, because both of them are at the same what amount of what charge. So Newton per what coulomb. So this one answers our what, question A. So let us look at question B. Question B says, for similar charges in opposite what direction. So now, for similar charges in opposite direction, since both of them are what, acting opposite to each other, what we do, we are going to have what, an effective strength, which will now give us what, E1 plus E2. At the end of the day, just add the two values together. 1.6 times 10 raised to the power 6 plus 1.6 times 10 raised to the power 6. So do the summation and give us the answer. At the end of the day, we are going to have just add this one and this together. 1 plus 1 is what? 2. Then 6 plus this one is 2. Carry 1, then plus this one. Then we have a 3.2 times 10 raised to the power 6 Newton per what? Coulomb. So this is the effective strength, the electric field strength or the electric field intensity acting between the two charges. If you find this class very interesting, please do not hesitate to share these videos. And for those of you that are writing JAMB and WAEC, don't fail to chat us up. If you have questions, want us to help you to solve, write it in the comment section. God bless you. Bye.